The year is 2057. The sunlight is fading and the cold on Earth is continuously increasing. Sheets of ice are spreading everywhere and the end of humanity is drawing near. Crops are dying, cities are becoming deserted, and the world is on the brink of a new ice age. Scientists believe that a mysterious particle called cue ball in the core of the sun is disrupting its nuclear fusion process. This is the last hope to stop this disaster. Icarus-1, a spacecraft carrying 8 astronauts and a massive stellar bomb, is heading towards the sun. Its mission is to reignite the dying sun, but the spaceship is lost before it can reach the sun. After a certain point, communication is lost, so no one knows what happened to it. Meanwhile, the situation on Earth gets even worse, and the entire planet starts to freeze. About 7 years after the previous mission, the Icarus II mission is launched again with a new crew, but this journey is not easy. Technical failures, tension among the crew members, and a strange threat. Icarus, the captain of Icarus Tata, yes, the mission that disappeared earlier, its captain is determined to destroy this mission. This is the story of the 2007 science fiction movie Sunshine. But the question is, can this really happen? Can the sun really die so soon? And if the sun actually starts dying, can we humans save it? In today's thrilling journey, we will try to understand this cosmic mystery. If something abnormal happens to the sun, what will happen to humanity? So get ready for a journey that will make you think. The movie Sunshine takes us to a world where the brightness of the sun is fading. The film shows that a theoretical particle called cue ball is stopping nuclear fusion in the core of the sun. Cue ball is actually part of supersymmetric physics. It says that during the Big Bang, some particles might have formed that could destabilize the core of a star. But it's also true that we haven't found any solid evidence of cue ball so far. It's just a mathematical concept that's being studied in labs like Conseil Européen pour la Recherche Nucléaire. This idea from the movie's scientific consultant and Conseil Européen pour la Recherche Nucléaire physicist Brian Cox turned the movie into a cinematic thriller. The mission of Icarus Y is to detonate a stellar bomb in the core of the sun so that nuclear fusion can start again. But the crew faces many challenges. The spaceship's shield struggles to withstand the sun's intense radiation. The crew members sent on this mission fall victim to psychological stress. And then the captain of Icarus-1, who is immersed in religious fanaticism, tries to sabotage this mission. The climax of the film leaves you with the question, was the sun saved, and at what cost? But when we look at our real world, can a nuclear bomb really reignite our sun? The answer is no. The sun produces as much energy every second as 386 billion trillion megatons of trinitrotoluene. Even humanity's most powerful nuclear bomb, the Tsar Bomba, which was about 50 megatons, is nothing compared to this. The difference is so huge that it's hard to even explain. The temperature at the core of the sun is about 15 million degrees Celsius, and the pressure in its core is so high that any bomb would vaporize before even reaching there. Actually, our Suraj is so big that even if we wanted to reignite it, billions of our atomic bombs wouldn't be enough. But the main concern that comes to our mind from this movie is, can something like this really happen to our Suraj? Is it possible for the sun to die? Suraj, who holds our solar system together and sustains life on our Earth. It is an average star found in this universe. A main sequence star generates energy by turning hydrogen into helium. This nuclear fusion process has been going on for the past 4 to 6 billion years and will continue for the next 5 to 7 billion years. Today we have understood the life cycle of the sun and stars very well. After about 500 to 600 million years, the luminosity of our sun will increase so much that photosynthesis on Earth will stop. This means that plants will die and 99% of life on this Earth will be wiped out. About 5 billion years after that, the sun's hydrogen will start to run out and the sun will turn into a red giant. So big that it will swallow Mercury, Venus, and maybe even Earth. Then it will blow off its outer layers to form a planetary nebula and its core will shrink into a white dwarf. a small cold and dead star. But in sunshine, it is shown that Suraj starts dying in 2057. Is that scientifically possible? The answer is almost no. Suraj dying so quickly goes against natural processes. This would require an extreme cosmic event such as cue balls, a stellar collision, or a gamma ray burst, which would make Suraj's core so unstable that it would destroy itself. But the probability of any such event is so low that astronomers practically consider it zero. According to scientists, everything in the universe follows the laws of physics, and stars do the same. It's not possible for the sun to run out of its fuel so quickly, but still, let's assume if that happens, what will happen to us? The sun's brightness will eventually decrease, causing Earth's temperature to fall below zero in days. All the oceans on Earth will start to freeze and there will be no light. So photosynthesis will also stop and the food chain will completely collapse. In just a few months, the Earth will become a desolate ball of ice. But if this happens, can we save our sun? The idea of a stellar bomb in the movie Sunshine is quite exciting as cinema, but it's scientifically impractical. If we also make a plan to reignite the sun like in the movie, we would have to restart nuclear fusion in the core of our sun. For this, we would need to inject hydrogen fuel into the core of our sun. But the sun's core is so dense that its pressure is millions of times greater than the core of our Earth. Any material would be destroyed before even reaching there. In such a situation, the idea of reigniting the core seems completely imaginary, and even if somehow we managed to reach the sun's core, its effect would be negligible compared to the sun's massive energy output. To match the sun's energy production, we would need stellar mass energy, which is billions of times more than humanity's current capability. But is there any other way? There are some theoretical options for this. The first is stellar lifting. In this technique, hydrogen and helium are extracted from the outer layer of the sun and injected back inside to increase its fuel. This can extend the sun's lifespan by a few billion years. But for this, we would need futuristic technologies like magnetic field or gravitational manipulation, which currently exist only in our imagination. The second option is to build artificial fusion reactors and inject hydrogen into the sun's core. The third idea is to use high-energy particle beams or lasers to boost nuclear fusion in the sun's core. But for this, we need an intense amount of energy. There will be Jal, the last option to save ourselves from such a catastrophe. Planetary migration means taking Earth to another star system like Proxima Centauri, which is well shown in the movie The Wandering Earth. But for this, we would need light-speed propulsion and generation ships, which currently exist only in our theoretical concepts. Another idea is to compress the sun so that its core heats up again. But for this too, we would need a gravitational force like that of a black hole, which is impossible. National Aeronautics and Space Administration scientists say that we have a lot of options, but the biggest problem is with them. Our technology is currently at the level of a Type 0 civilization. To manipulate a star like the sun, we would need the level of a Type 2 civilization. But right now, we aren't even able to fully manage our basic energy needs. On the Kardashev scale, we are not yet ready for stellar engineering. If the sun suddenly started to die, we wouldn't have any time to do anything in such a situation. What would happen on Earth if the sun's luminosity suddenly started to decrease? Even though we've recently learned how to mimic the sun, we're still not advanced enough to engineer our own sun. If the sun's light starts to decrease, there will undoubtedly be chaos all over the world. People will start trying to adapt to this mysterious change, but soon they will begin to realize that this is not just any ordinary change that human civilization will be able to endure. The temperature across the entire entire Earth will start dropping rapidly, leading to the beginning of a new ice age. Those who are not aware of this great catastrophe will lose their lives, or we can say that they will just die a little earlier. If trees, plants and oceans don't get light and energy, the Earth's ecosystem will collapse and the food chain will break right there. Crops will be destroyed and everywhere animals and people will start dying of hunger. Even knowing that the world is about to end, people will struggle to live for just one more moment. Riots and chaos will become common everywhere. On the other hand, space agencies and governments will be busy figuring out how much time Earth has left and how many resources we have left to defend ourselves. If scientists find any solution to survive this apocalypse, then the entire effort will be put into completing that mission. And if we find any way to escape from this disaster, only rich people will be able to leave this world and create a new one. But humanity will die on this very Earth. Without the energy of the sun, Earth's magnetic field could also become weak because it interacts with the solar wind, which would cause cosmic radiation to start leaking into Earth's atmosphere, which will put the remaining life here in even more danger. But that will only happen if our sun starts to die right now. But the chances of that are almost zero if the sun dies slowly according to its age. When it turns into the red giant phase, the sun will become so big that Mercury, Venus and maybe even Earth will be swallowed up too. And even if Earth survives, its surface temperature will increase so much that it will turn into a hell like Venus, a toxic, scorching world where life is impossible. But even in such situations, there is always a ray of hope somewhere. In a recent astronomy study, an Earth-like planet was discovered that survived its star's white dwarf phase. The star lost some of its mass and the planet's orbit shifted slightly outward, but this won't happen for billions of years. If somehow the sun started to die in 2057, we wouldn't have any time to prepare for it. What options would humanity have if the sun's light started to slowly fade? If the scenario shown in the movie became a reality in our world, humanity would have some theoretical solutions that they could try to use to survive this catastrophe. Underground shelters can protect us from the cold weather on the surface. Geothermal energy and nuclear reactors can make survival possible for some time, but the lack of oxygen and food makes this only a temporary solution. If we want to survive for a long time, we will have to find another way, and that way is could be space colonies. Self-sustaining colonies can be built on Mars or on Jupiter's moon Europa. But for this, we will have to develop technologies like closed-loop ecosystems, artificial gravity, and radiation protection. Currently, our space exploration is limited to Mars rovers and the International Space Station. It may take us decades or even centuries to build colonies. This shows why we should grow our technology quickly. But building space colonies won't solve all our problems. No matter where we colonize in our solar system, as long as we don't have the sun for energy, our survival will be very difficult, and for survival, we will have to reach interstellar migration very quickly. If we can go to star systems like Proxima Centauri, then humanity can surely survive. But for interstellar travel, we will have to develop technologies like light speed, propulsion, and generation ships as soon as possible. But even if we can't do all that, it doesn't mean we have no hope. The energy that the sun gives us, we will have to get that energy from somewhere else, which means we will need it. Alternative energy sources like nuclear fusion reactors or geothermal power plants could try to keep life going on Earth if the sun's energy runs out. Currently, our fusion technology is still at an early stage. Projects like International Thermonuclear Experimental Reactor are still decades away. And if the sun has completely died, these solutions can only give us more time to stay on Earth. For its construction, we would have to devastate entire planets and use up all their resources. universe. And to do this, we would need the capabilities of a Type 2 civilization. Right now, we are still Type 0, but among all these possibilities, the biggest challenge will be time. If the sun is dying slowly, we might have a few hundred years. But if there's a sudden collapse, we could have anywhere from a few years to just a few weeks. Our sun is not just a star, it's the foundation of our civilization. It gives us energy, controls the climate, and makes life possible. Without the sun, the earth would turn into a cold dark rock. The movie Sunshine gives us a warning about how fragile our existence is. Our technology, our intelligence, and our willpower all depend on that star. But this movie doesn't just scare us, it also gives us hope. Humanity has always faced challenges. From the discovery of fire to space travel, we have made the impossible possible. Maybe in the future, we will master stellar engineering, maybe we will build space colonies or achieve interstellar migration. But for that, we have to start working from now. Even though the sun won't die in 2057, that doesn't mean we don't need to be prepared. Will we be able to prepare for such situations in time, or will we also have to burn in the sun's fire like the Icarus spaceship? Imagine a celestial body that is very large, very powerful, which, even from a distance of 93 million miles, is controlling life on a planet in every way. And now imagine that the body responsible for life on a planet is also hiding a very deep secret. Secrets that even scientists can't fully explain. Yes, we are talking about our sun. We think we know the sun, but do we really know it? What if I told you that there are forces brewing inside the sun that could wipe out all of human civilization in the blink of an eye? That familiar warmth we feel every day, we haven't even realized or understood the destruction it could cause. From the strange sunspots visible on its surface to the dangerous solar storms, the sun is not just a life-giving deity as we think. It's also a ticking time bomb that could explode at any moment with unimaginable force. So in this video today we will explore the dark side of our sun, which is unpredictable, violent, and extremely mysterious. After this, your perspective on the sun will change. From ancient civilizations that considered the sun a deity to today's modern science, which now sees it as the engine of life. Although we know that the sun is a huge ball of gas and plasma, but if we look at it on a broad scale, truly life is not possible without the sun. And humanity has known from the beginning that the sun is essential for us. But that same sun is also one of the most dangerous forces in our solar system. Apart from its warmth and familiar light, it's an uncontrollable cosmic nuclear furnace that is constantly leading us toward a major event. We take the sun for granted, which, in this endless universe, is lighting up the planets like a giant lamp. It keeps them warm and also sustains life on those planets. If we go deep into the sun, the gravity there is so intense that even hydrogen atoms collide and fuse together. Through this process of nuclear fusion, the entire sun releases an immense amount of heat, and that's how the surface temperature of the sun reaches up to 5,500 degrees Celsius. But the real terror is hidden in its core, where the temperature rises up to 15,000 degrees Celsius. 15,000 degrees Celsius. This is beyond our imagination. This immense energy of the sun not only gives us light, but also creates storms on the sun. There is also a massive ejection of magnetic fields and charged particles there. Even though solar flares and solar mass ejections may not seem very dangerous to us, they have enough power to destroy our modern technology in an instant. A single solar storm can push us into a global blackout. To be honest, we are literally living at the mercy of a star which can change its course at any time. And the scariest thing is that it neither recognizes us nor is it compassionate. So let's take a look at a dangerous example of the sun's power, a solar storm. In 1869, a massive solar storm was released from the sun, which we now know as the Carrington event. This solar storm was so intense that the telegraph system of that time broke down. Equipment caught fire, and the operators working on those systems and equipment received strong electric shocks. If such a storm hits the Earth today, destruction is certain. Our modern world is highly dependent on technology. The result will be that the internet, global positioning system power grids, and satellites will be fried in just a few moments. These are the main resources where its impact will be most visible. Apart from this, people traveling by sea and air will get stranded in the middle of their journey. There are also some devices in our bodies that can conduct electricity. In this situation, the risk to life and property will rise significantly. A large amount of magnetic energy is released from the sun's atmosphere, and this explosion is called a solar storm. These solar storms can release highly charged particles into space in any direction, and when they head towards the Earth, they travel at a speed of millions of miles per hour towards our planet. When these storms collide with the Earth, they interact with its magnetic field. Because of this, we see beautiful auroras in the sky. But behind this beauty are these terrifying solar storms, which can destroy everything in an instant. The scariest thing about them is that we can't see them coming. Solar storms erupt without any warning. One moment the sun is completely calm, and the next moment it can release this invisible dangerous radiation toward us. The Carrington event was a warning for us, but we have come a long way by learning from this event. For decades, space agencies and scientists have been constantly monitoring the sun for such solar storms so that we can protect ourselves in time. The question is not whether the next solar storm will hit us, but rather when will it happen. This uncertainty always keeps us afraid. The sun has another dark side, sunspots. When we look up at the sky and see the sun, we see its dazzling, blinding brightness. But it doesn't always shine like this. Sometimes dark spots also appear on its surface, which are called sunspots. These are cooler regions present on the surface of the sun, where the sun's magnetic fields are twisted and tangled together. We have been observing sunspots for centuries, but the reason for their formation has always remained a mystery. But what we do know about them is that wherever sunspots occur, there is destruction. Sunspots are connected to the activity of our sun, and sunspots are also the root cause of many intense solar storms. These dark spots indicate some terrifying processes happening inside the sun which we still haven't been able to understand. But why do they form, and why do these sunspots trigger solar flares and coronal mass ejections? These questions also force scientists to think. What we do know about them is that sunspot activity increases and decreases in cycles. When the sun is most active, more sunspots are also observed, and the more sunspots there are, the higher the chances of solar flares. That's why, during the sun's 11-year activity cycle, we see more solar flares and increased solar activity. Next time you see a picture of a sunspot, remember that these are not just spots on a shining star. This is the sun's dark side, which is the most dangerous. And we must also remember that we live peacefully under the shelter of a star that is not peaceful at all. But sunspots are not the only danger coming from the sun. The sun has another dark side, solar flares. Solar flares are the sun's own way of releasing suppressed energy. And when these flares erupt, the energy released from them is even greater than the energy of millions of atomic bombs. These flares release radiation and charged particles in every direction from the sun, and sometimes they come directly toward our Earth. When a powerful solar flare hits our Earth, the effects can bring our entire world to a halt. Global blackout, disappearance of global positioning system signals, malfunctioning of satellites, failure of power grids. The entire internet economy ecosystem can come to a standstill. Just one flare hitting us can suddenly bring the banking system, aviation industry, and all other sectors that depend on the internet to a halt. This reminds us that the same sun because of which our Earth is alive, that very sun can force our Earth, our world to come to a standstill. But solar flares are not the only mystery of our sun as we are becoming more advanced. Our understanding about the sun is increasing even more. But there is still so much about the sun that we have not been able to understand. For example, the sun's corona, its outermost layer, is a mystery because its temperature is much higher than the surface of the sun. How is this possible? The surface of the sun, which is as hot as 5,500 degrees Celsius. How can the temperature of the corona, which is hundreds of kilometers away from it, be millions of degrees Celsius? Another mystery is what force is driving the solar cycles. Every 11 years, the sun's magnetic poles flip, which increases solar activity. But scientists have not been able to find out the driving force behind this. It gives us a glimpse of what is happening, and this tells us how much we have understood this infinite universe and where we actually stand. Suraj is our closest star, but this universe is infinite, and such mysteries make this universe the supreme leader. Because in this universe, everything runs according to the rules made by the universe itself. And maybe it's better if some mysteries remain hidden forever. If someone like Sabita learns every secret of the universe, she will become the supreme leader and will want to run the rules of the universe according to her own will. And maybe none of us would want that. Interstellar travel is quite terrifying. Your spaceship is cramped and the freezing cold of the galaxy and dangerous cosmic rays could take your life. That's why, to survive in the harsh conditions of space, it's much safer for us to live on Earth where we have a biosphere, a protective magnetic field, and unlimited energy from the sun. But what if we become capable of living in all galaxies? Yes, I don't know if we can definitely do this or not, but yes, moving the sun could be an amazing thing. Now you must be thinking, when it's so hard to even reach the sun, how can we possibly move it? However, it will take us at least several centuries to do this, and that's exactly what I'm going to tell you today, how we can move the sun. So let's take a look at this interesting theory. Friends, this is exactly Newton's law of motion. As Newton's first law tells us, if something is at rest or moving in a straight line at constant speed, it will remain in that state. Or it will keep moving in a straight line at constant speed until an external force is applied to it. Now in the same way, suppose that the mutual gravity of the rest of the galaxy keeps the sun in its orbit, but for an object it might be possible to change its motion using propulsion. Similarly, Newton's third law says that every action has an equal and opposite reaction, meaning every action has an equal and opposite reaction. For example, if you hit your head against the wall will apply a similar and opposite force on your head. Now suppose a rocket blasts its propellant. The explosion pushes the rocket forward. This is just conservation of momentum. A stellar engine works exactly on this principle. However, moving something as huge as the sun seems nearly impossible. Its mass is about 300,000 times that of our Earth, and its diameter is about 109 times greater than Earth. For your information, mass measures the amount of substance in something and stays constant, no matter where an object is located. The first plan to move the sun was proposed by Fritz Zwicky. Zwicky had many such thoughts. He was the first person to consider the possibility of dark matter, and he had also predicted the existence of neutron stars and gravitational lensing long ago. The very first stellar engine was proposed in 1961. It was a massive particle accelerator in space, which fires shrapnel at the sun at nearly the speed of light. But this proposal inspired humans to at least think about ways to move the sun. However, the next serious proposal came sometime later. In the 1980s, Soviet aerospace engineer Leonid Shkadov came up with one for which no external energy source, not even propellant, is required. The Shkadov thruster relies on the fact that life is a self-moving object. Each of those photons carries away speed. Now, the thing here is that photons are emitted from the sun in every direction, which move away from the sun at the speed of light, and in this way, they also push the sun in the opposite direction. However, this push is very small, and since photons are emitted equally in all directions, the force exerted on the sun by those photons is very small, and that's why the sun always stays in a steady position. But what would happen if the sun shined more in one direction? On this, Shkaidav believes that a giant parabolic mirror made of an ultra-thin foil the size of a planet's orbit should be built, because the photons hitting the mirror will be reflected back. In this process, the speed will be transferred to the mirror. Here, mirror doesn't mean a regular mirror, but a solar foil that operates with sunlight and pulls the sun. How does this work? Let's see. The first approach says that we consider the sun and the mirror as a single system which emits light radiation in one direction, whereas for conservation of momentum, it is necessary that the system moves in the opposite direction. The second way would be to think of the mirror as a large gravity tugboat. In this explanation, the sun's radiation actually causes acceleration in the direction opposite to the photons coming from the mirror, but the solar sail's own gravitational field pulls the sun a little, causing our star to pick up speed along with the solar sail. If we assume that our solar system is about to be destroyed by the kill zone of an impending supernova within 100 light years, then we'll always need more movement than what is provided by the thrust of the Kardashev thruster. In the future, foreign civilizations will construct a massive reflective structure on one side of their star. The star's light will hit this structure and bounce off, pushing it away. If this reflective structure had enough mass, it would also attract the star with its own gravity. If future civilizations can achieve a perfect balance with this, they will be capable of using the star's own light to pull the star through the galaxy. First, it will give you a lot of speed, and by that time, the star will have traveled almost 0.3 light years. Which is less than 10% of the distance to Alpha Centauri. If we keep this up for 1 billion years, we will move forward thousands of times faster. Imagine a future civilization using this technique to move its star to better locations, or even recharging vast parts of the galaxy for its energy objectives. This might sound theoretical, but Duke and Forgan from the University of Edinburgh suggests a practical way to search for aliens moving their stars. According to them, you can use planet hunting telescopes like Kepler to detect strange light signals caused by these kinds of thrusters. But there's nothing in the laws of physics that says this can't happen. It's fun to think about, and it gives us a new way to search for alien civilizations across the galaxy. Ever since Freeman Dyson first thought of his famous idea, a lot of observations related to it have been made. Sometimes they've searched for excess infrared radiation that would escape detection, and sometimes they've looked for strange flickering caused by revolving panels that obscure the star. Scientists have calculated how a star could slow down if a shadow thruster is rotated over it. Maybe just like how aliens might keep watching to change the direction of their star. It's not surprising that those searches turned up empty, but that doesn't mean that stars can't be moved artificially or that such aliens don't exist. The only difference is that they don't exist in sufficient numbers or at high enough speeds or in a disrupted orbit, and they can't be observed either. So can a stellar engine ever be built? We don't know, but the fact is that it might be built someday. This isn't something we should try right now, but yes, we can say for now that maybe in the future this could be possible. Maybe our future civilization comes up with the technology to move the sun, and maybe this could be possible. However, forget about touching or moving a giant star like the sun. Right now, even reaching it is difficult. But the way human civilization is progressing, hopefully in the coming time, we will master this as well. The rest, let us know what you want to say about this topic in the comment section below. If you like this video, please like and share it. Friends, for more such videos, make sure to subscribe to our channel and enable the bell notification. Friends, we will meet again soon with another new informative video like this. Till then, stay curious, be happy, and goodbye.